Water is life. It is the essence of our existence, the foundation of all living things. Without it, life as we know it would cease to exist. It's a simple statement, yet it holds profound truth. Every drop of water is a miracle, a testament to the delicate balance of our planet's ecosystems. As our planet grapples with the growing challenges of climate change, access to fresh water is becoming increasingly precious. Glaciers that once fed our rivers are receding, and weather patterns are becoming more unpredictable. Droughts plague vast regions, impacting agriculture, ecosystems, and human lives. The sight of cracked earth and withered crops is a stark reminder of the fragility of our water supply. But what if we could lend nature a helping hand? What if we could harness the power of technology to bring rain to the places that need it most? What if we could summon rain from the skies, replenishing parched lands and securing our water future? Imagine the transformation of barren landscapes into lush green fields teeming with life. This is the promise of artificial rain, a field of science that has captured imaginations and sparked debate for decades. From early experiments to modern advancements, the journey of weather modification is a fascinating one. The idea of controlling the weather might seem like something out of science fiction, but it's becoming increasingly real. With sophisticated technology and a deeper understanding of atmospheric processes, we are closer than ever to making it a reality. Artificial rain, also known as weather modification, encompasses techniques aimed at influencing precipitation patterns. These methods include cloud seeding, where substances are dispersed into the air to encourage cloud formation and rainfall. While still a developing field, it holds the potential to revolutionize how we manage water resources, particularly in areas facing water scarcity. The benefits could be immense, from boosting agricultural productivity to replenishing vital water reservoirs. Imagine communities thriving with a reliable water supply, children playing in the rain, and farmers working in fields that are no longer at the mercy of drought. The dream of making rain in a thirsty world is not just about technology, it's about hope, resilience, and the future of our planet. Achieving this dream requires global collaboration. Scientists, policymakers, and communities must work together to develop and implement these technologies responsibly. The future of artificial rain is a testament to human ingenuity and our collective effort to safeguard our most precious resource. As we look to the horizon, we see a future where technology and nature coexist harmoniously. A future where we can make rain in a thirsty world, ensuring that every drop counts and every life flourishes. At the heart of artificial rain lies cloud seeding, a technique that mimics nature's own rainmaking process. This innovative method has been developed to address water scarcity and enhance precipitation in areas that need it the most. By understanding and harnessing the natural processes that lead to rainfall, scientists have found a way to give nature a little nudge, helping to bring much-needed rain to parched lands. Imagine a cloud pregnant with moisture, but lacking the necessary ingredients to release it as rain. These clouds, though heavy with potential, drift aimlessly across the sky, unable to fulfill their promise of rain. This is a common scenario in many drought-stricken regions where the atmosphere holds moisture. But the conditions are not quite right for precipitation to occur naturally. This is where cloud seeding comes in. It involves introducing tiny particles, known as cloud condensation nuclei, into the atmosphere. These particles can be dispersed from aircraft or ground-based generators, strategically placed to maximize their impact. The goal is to provide a catalyst that encourages the formation of raindrops, turning potential into reality. These particles act as seeds, providing a surface for water vapor to condense around. As the water vapor gathers on these nuclei, it forms droplets that grow larger and heavier, eventually falling to the ground as rain. This process is a delicate balance, requiring precise conditions and careful monitoring to ensure success. These particles can be natural, like dust or sea salt, But cloud seeding often utilizes artificial substances chosen for their effectiveness. Natural particles are abundant in the atmosphere, but they are not always present in the right quantities or locations to induce rainfall. By introducing artificial particles, scientists can control and enhance the process, making it more reliable and efficient. The most common of these is silver iodide, a compound that closely resembles the structure of ice crystals. Silver iodide is particularly effective because it can initiate the formation of ice in clouds, even at temperatures where natural ice formation would not occur. This makes it a versatile tool for cloud seeding, capable of inducing both rain and snow. When released into a cloud with the right conditions, silver iodide particles act as artificial ice nuclei, promoting the formation of raindrops or snowflakes depending on the temperature. This process not only helps to alleviate drought conditions, but also supports agricultural activities, replenishes water reservoirs, and can even reduce the risk of wildfires by increasing moisture levels in the environment. Through cloud seeding, we are able to lend a helping hand to nature, ensuring that the vital resource of water is available when and where it is needed most. The process of cloud seeding involves dispersing the chosen particles into the target clouds. This can be done in a few ways. Ground-based generators, often placed in mountainous regions, release plumes of silver iodide into the air, where they are carried upwards by air currents into the clouds. Alternatively, aircraft equipped with special flares or canisters can fly directly into cloud formations, releasing the seeding agents. Besides silver iodide, other substances have been explored for cloud seeding, each with its own properties and potential benefits. Dry ice, or solid carbon dioxide, can be used to rapidly cool cloud regions, promoting ice crystal formation. Some research has even investigated the use of hygroscopic materials, such as salts, which attract water vapor and enhance droplet growth. Section 4. Successes and limitations. Does cloud seeding really work? The effectiveness of cloud seeding has been a subject of scientific inquiry and debate for years. While numerous studies have shown promising results, demonstrating increased precipitation following seeding efforts, definitively quantifying its impact remains complex. Weather systems are inherently chaotic and influenced by a multitude of factors, making it challenging to isolate the precise effect of human intervention. Moreover, cloud seeding is not a magic solution for all water woes. It requires specific atmospheric conditions to be effective. Clouds must be of a suitable type, containing sufficient moisture, and the presence of natural ice nuclei can influence outcomes. In some cases, seeding might even have unintended consequences, such as altering wind patterns or potentially leading to localized increases in hail. Section 5. Global examples. From the UAE to China, rain from the skies. Despite the challenges, cloud seeding has been embraced by numerous countries facing water stress, particularly in arid and semi-arid regions. These regions often suffer from prolonged droughts, leading to severe water shortages that impact agriculture, industry, and daily life. The need for innovative solutions to address these water crises has never been more urgent. The United Arab Emirates, for instance, has invested heavily in cloud seeding research and operations, aiming to enhance rainfall and replenish its scarce water resources. The UAE's National Centre of Meteorology has been at the forefront of these efforts, deploying aircraft equipped with flares that release salt particles into the clouds. These particles act as nuclei around which moisture can condense, eventually leading to rainfall. Their efforts have involved advanced technologies, including drone-based seeding and sophisticated weather modeling. Drones offer a more flexible and cost-effective method for cloud seeding, allowing for precise targeting of specific cloud formations. Additionally, weather modeling helps scientists predict the best times and locations for seeding, maximizing the chances of successful rainfall. China is another prominent player in the field of weather modification. The country has a long history of using cloud seeding to combat drought and improve agricultural yields. In recent years, China has expanded its weather modification program, investing billions of yuan into research and development. The country has ambitious plans to influence weather patterns on a massive scale, aiming to increase rainfall in drought-stricken areas and even suppress hailstorms that can damage crops. Hailstorms pose a significant threat to China's agricultural sector, and cloud seeding is seen as a viable method to mitigate this risk. By dispersing chemicals like silver iodide into storm clouds, China aims to reduce the size of hailstones, thereby minimizing damage. Their efforts highlight the growing interest in cloud seeding as a tool for mitigating the impacts of climate change and ensuring water security. As global temperatures rise and weather patterns become more unpredictable, the ability to influence rainfall could prove invaluable. Countries like the UAE and China are leading the way, demonstrating that with the right technology and investment, it is possible to make rain from the skies.